Now I am going to discuss some of the properties of discrete time Fourier series. The first property of discrete time Fourier series is linearity property. So let's see it. If x of n and y of n be two periodic signal, then x of n has Fourier transform x of k and y of n has the Fourier transform y of k. So z of k is ax of n plus by of n, which can be written as zk equals to ax of k plus by of k. Now we are going to prove it. Z of k is 1 upon n summation over n equals to capital N time period e raised to power minus j k omega naught n. Now using the above equation zk, we can write this very equation as ax of n plus by of n into e raised to the power minus jk omega naught n. Now putting a outside this bracket, we get now the whole becomes x of k and this very equation becomes y of k, so it can be written as ax of k plus by of k. So this proves the linearity property for discrete time Fourier series. Now the second property of discrete time Fourier series is time shifting property. Now the time shifting property of discrete time Fourier series states that if x of n has Fourier transform x of k and y of n has Fourier transform x of n minus n naught, then y of k can be written as x of k into e raised to the power minus j k omega naught n. So now I will prove it. Y of k equals to 1 upon n summation over now y of n can be written as x of n minus n naught by using this very equation. So it can be written as x of n minus n naught into e raised to the power minus j k omega naught n using equation 1. So putting m equals to n minus n naught, so n equals to m plus n naught. After that we would look at the properties of, means the value of yk. Yk equals to 1 upon n summation over, now the limit of n changes to, for m equals to minus n naught to n minus 1 minus n naught. Here n equals to 0, that is why when we put n equals to 0, m equals to minus n naught. And similarly, for the value of n minus 1, we get the limit of m as n minus 1 minus n naught. So x of m into e raised to the power minus j k omega naught m plus n naught. Now this very term xm, this very term is written as x of k into e raised to the power minus j k omega naught n naught. So here mod of y of k equals to mod of x of k. So the time shifting property of discrete time Fourier series gets proved. Now the third property of discrete time Fourier series is frequency shifting property. So in frequency shifting property, similarly, if x of n has a Fourier transform of x of k and y of n has e raised to the power j m omega naught n, then x of n and y of k is x of k minus m. So this is the frequency shifting property of discrete time Fourier series. Now I am going to prove it. Now y of k can be written just similar in the previous questions. For n equals to n time period, x of n into e raised to the power minus j k omega naught n. Now this can be also written as for the y of n. So the limit gets changed and it becomes n equals to 0 to n minus 1 y of n into e raised to the power minus j k omega naught n. So this can be written as to the power j k omega naught n into x of n into e raised to the power minus j k omega naught n. Here y of n can be written as this very form. So y of k equals to 1 upon n summation of n equals to 0 to n minus 1 x of n into e raised to minus j k minus m omega naught n, and this is just similar to x of k minus, and this is just similar to x of k minus n. So here we prove the frequency shifting property for discrete time Fourier series, and now it's time for the time reversal property. So the statement for the time reversal property is this: if y of n has Fourier transform of x of k, and y of x of n has Fourier transform of x of k, and y of n is equals to x of minus n, then y of k is equals to x of minus k. So this is the time reversal property of discrete time Fourier series. And now the proof of this property is like this formula that we have used in the previous proofs also, that y of n equals to y of k equals to 1 upon n summation of n equals to over one time period of n y of n into e raised to the power minus j k omega naught n. Similarly, this can be written over for the time period n equals to 0 to n minus 1 time period y of n into e raised to the power minus j k omega naught n. So we would now replace y of n with x of minus n. So the limit remains as it is, and it becomes x of minus n into e raised to the power minus j k omega naught n. So it is, now the limit gets changed for the n equals to minus of n, capital N minus 1 to 0, and it is x of m into e raised to the power minus j plus k omega naught m. Sorry, it is x of n, and now it is just similar to x of minus k. So the time reversal property which gets proved here, that y of k equals to x of minus k. So the last property for the discrete time Fourier series is Parseval's relationship. So now I am going to prove the Parseval relationship. So the Parseval relationship is, if x of n has Fourier transform x of k, then 1 upon n summation over n equals to capital N x of n whole square is equals to summation of k equals to n mod of x k whole square. So proof for the Parseval relationship is, first of all we are considering the LHS part. So the left hand side part of the above equation is 1 upon n summation over n equals to capital N mod of x n whole square is equals to, and it can be written as summation over x n equals to n x of n into x complement of n. We put this x of n out of the bracket, and we would write the value for the x complement of n as x of k into e raised to the power j k omega naught n. Now we would write it as 1 upon n summation over n equals to capital N x of n k equals to one time period. Here I am forgotten to write the x complement of k, and here also the x complement of k into e to the power minus j k omega naught n. So here when we put x k complement outside the bracket, so x k complement 1 upon n summation over n equals to one time period x of n into e to the power minus j k omega naught n. We have just put this x complement of k outside the bracket and whole things inside it. So this can be written for the whole time period xk complement into x of k, which is magnitudes by equal to the statement of the Parseval relationship that we have studied earlier. So here we get proof of the fifth property of discrete time Fourier series, that is a Parseval relationship. So it is not the end of the question number 2, which is the properties of discrete time Fourier series. Thank you.